Hello everyone. In this video, we're going to look into how to find the domain and range of a graph. Alright, so for this problem, we're going to use a previous question, which is problem number 8. And just as a reminder, what we did in problem number 8 is we applied the vertical line test. And as you can notice here that a graph is not representing a function if there is one vertical line that intersects the graph in more than one point. So here is intersecting in 3 points. So this is not representing a function, right? However, on the other side, if we cannot find any vertical line that intersect the graph more than once, then this graph could be representing a function. So therefore, we noted that for C is not a function, and the reason because we have 2 points here or one vertical line is enough, one vertical line, and that is not going to be a function, right? For D, neither, so not a function, and for the same reason we have 2 points belong to the graph and on the same vertical line. For E, although they are points, we have 2 points, only 2 points belong to the same vertical line. So this is not a function either, right? And finally for F is the same reason, we have one vertical line that intersects the graph in 2 points, right? Although the graph is separated in 2 segments, still is the same graph, right? So this is not a function. So the only 2 graphs that could represent a function is A and B. And you can notice here we cannot find any vertical line that intersect the dots or the graph in more than one point, right? So this is a yes as a function and this is a yes in function. So now I'm gonna focus only on A and B, since they are the only 2 functions. I don't think they will ask you to find the domain and range of a graph that is not a function in this class, right? So that's beyond this level. Okay, so let's focus on A and B only, right? All right, so this is graph A, and before starting the question, we're gonna define what's the domain of a function, right? So whenever you have a graph, I think the easiest way to understand the domain is by making the projection of the graph on the x-axis. All right, so since we are making the projection on the x-axis, so let me highlight it for you. This is the x-axis. So the only projection that can happen there is a vertical projection, right? So what does mean projection? Is like a shadow. So you drop this point here and you get this coordinate in there. So you drop the shadow of this point here and you're gonna get this coordinate over there. And from the other hand, if it is below that line, we're gonna make the projection upward. So the projection can go upward or downward, right? And that's basically all the points. And then you're gonna open a set, all right? That's the notation of a set. That's how you open and how you close it. And then we're gonna put all the coordinates of the points that are in there, right? So probably the numbers are not really clear. This is a -2, this is a -3, this one is a -4, and this one -5, all right? And this one of course is 2. So the numbers are, I'm gonna put them and -5 and then separate them by comma, right? And then put the next one, -4, comma, -3, comma, -2, comma, and 2. So these points here, this coordinate represent your domain. Now for the range, we're gonna do exactly the same thing. However, the projection is gonna be on the y-axis. Alright, so the range is the projection of the graph on the y-axis. Now let me get rid of this for a moment, and let's see where is the y-axis. So the y-axis is right here, the vertical line, right? So the only projection you can do there is gonna be a horizontal projection, right? So the shadow horizontally, right? So that's gonna be in 2. This one is gonna be in 1. So you read them, you read the coordinate on the y-axis, right? These two here together, they have the same shadow, and that's gonna be -3. And the last one here is gonna be a -5. So now you notice these 2 points here, they have the same shadow and they are on the same horizontal line. We don't have any contradiction here, since functions only have to pass the vertical line test. We don't have a horizontal line test. So these points still represent a function. All right. So let's do the same thing. Open a set here, close the set, and we're gonna put inside the numbers, right, that we saw. I usually go from smaller to larger, but the order is not important, right? So the numbers are -5, comma, -3, comma, 1, and finally it's gonna be 2. And that's gonna be your range. And that's it for A. All right, so we are in letter B. So we have a graph of a function over here, and we want to figure out what the domain and range. So as we defined earlier, the domain is going to be the projection of the graph on the x-axis. So the x-axis is going to be this one, and you are looking for the shadow of this function, right? So if the shadow of the function vertically, right, so you're projecting vertically, so this is the shadow, you're going to be projected in there. The shadow from the bottom here, you can be projected upward, and so forth. So whatever on top, you're going to be projected down, whatever on the bottom, you're going to be projected upward, right? So now the set of points that is having the shadow, you can see the shadow is everywhere here, right? And since this function keep going all the way up and down, all right, so shadow is gonna keep going, right? So we're gonna assume here you're gonna come from all the way -infinity, and you keep going to all the way to +infinity. So therefore this is an interval, is not only dots. All right, so what does mean here, you have to use interval notation, and this one you're gonna start from -infinity all the way to +infinity. Well, we can call this one as well as R real numbers, which is the symbol of R real numbers, right? So capital R. Now let's go to the range, and the range again be the shadow of the function on the y-axis, so projection. All right, and this projection is going to be horizontally. So let's do the horizontal projection as well. So this is your axis that you're gonna look for the shadow on, right? And if you are on the right, the shadow is gonna be going this way, right? And this one is gonna be double shadow, is fine, and triple shadow, right? And keep going. So the shadow stop at the yellow point, right? And from the other side, the shadow is gonna be coming this way, right? So there you go, and this is the shadow going this way. So we don't read the shadow, we read it only here, from this point here all the way to this point. So the highest point is going to be coming from this part, and to the lowest point is going to be coming from this part. Well, probably is not really precise here, probably they meant 2 and -2, but anyway, so let's suppose this is 1.5, right? So if you are in exam condition, ask for the exact number, right? So suppose this is 1.5 in here, and this one -1.5. So therefore the shadow is only that red part over there, right? so whatever you can read on the y-axis. And since this point here is attained, all right, so it's shadow, so there is a shadow here, so it's not an empty point, so it has to be shaded or closed. The same thing over here, right? So this is point is, you are reaching this point, so this should be a shadow there. Shaded point means closed. So then if I start from the bottom, it's gonna be minus 1.5, and this is closed, and you're gonna reach all the way to 1.5, and as well this one is closed. All right, so that's your domain and that's your range, right? That's all.